Today we are learning about the U.S. Northwest Mountains. But first, review time. Here we have the entire United States of America. And like we did in review last session, we will review the last 3 sessions in addition to learning about our new geography today. I'll give you a little bit of time to answer each question on your own, followed by the reveal of the geographical point to see if you were right. Let's zoom in. First, we'll review the Northern Appalachians. What is the name of this mountain range? If you said White Mountains, you would be right. Next, we have this mountain range. What is it called? If you said the Green Mountains, you would be correct. What is this mountain range called in New York? If you said the Adirondacks, you would be right again. Name this mountain range. If you said the Allegheny Mountains, you would be right. Now, on to review the Southern Appalachian Mountains. To begin with, we don't have a mountain range, but a valley that runs through all of the Appalachians. What is this valley called? If you said the Great Valley, you would be correct again. Next, what is this mountain range called? If you said the Blue Ridge Mountains, you would be correctamundo. What is this smaller mountain range called? If you said either the Great Smoky Mountains or maybe just the Smokies, you would be right. Now for our last mountain range within the Appalachians that we have learned about. What is this beautiful mountain range called? If you said the Cumberland Mountains, you would be correct. Now moving over to the Blue Ridge Mountains, there is a mountain that is the highest elevation west of the Mississippi River. What is the name of this mountain? If you said Mount Mitchell, you would be correct. Heading west. What is this prominent mountain range that is the second largest in the world? If you said Rocky Mountain Range, you would be right. Next, what is this mountain within the Rocky Mountain Range called? If you said Pikes Peak, you would be correct. Not too far off is this 14er, the tallest mountain in the Rockies. What is this mountain called? If you said Mount Elbert, you would be right. Moving further west, we have a mountain range that is mostly in California with a small portion located in Nevada that casts a rain shadow, making Nevada the driest state in the U.S. What is this mountain range called? If you said Sierra Nevada, you would be correct. Within the Sierra Nevada is the tallest mountain in the lower 48 states. What is this mountain called? If you said Mount Whitney, you would be right. Now that we're done reviewing the last 3 weeks of geography, we will go on to learn about 4 geographical points in the Northwest United States, 1 mountain range, and 3 mountains. Going back to our map. To begin with, We have the Cascade Mountain Range that goes north to south from southern British Columbia within Canada down to northern California. Next, we have the first of three mountains, Mount Rainier. Moving a little south from Mount Rainier is Mount St. Helens. Lastly, for today's lesson, we head north to Alaska for the tallest mountain in all of North America. This mountain is called Denali. Moving right along, let's learn about the Cascade Mountain Range. The Cascade Range, or the Cascades, is a significant mountain range of western North America extending from southern British Columbia in Canada through Washington and Oregon to northern California. It includes both non-volcanic mountains, such as the North Cascades, and notable volcanoes known as the High Cascades. The small part of the range in British Columbia is referred to as the Canadian Cascades. The highest peak in the range is Mount Rainier in Washington at 14,411 feet. The Cascades are part of the Pacific Ocean's Ring of Fire, which refers to the ring of volcanoes and associated mountains around the Pacific Ocean. All of the eruptions in the lower 48 U.S. states over the last 200 years have been in the Cascades. The two most recent were Lassen Peak from 1914 to 1921 and a major eruption of Mount St. Helens in 1980, with some minor eruptions most recently from 2004 to 2008. The highest volcanoes of the Cascades, known as the High Cascades, dominate their surroundings, often standing twice the height of the nearby mountains. Visually, these mountains stand out and can be seen on clear days more than 100 miles out. Here, you see Mount Rainier from downtown Seattle, Washington. The distance between the two is 136 miles. Because of the nearness to the winds of the Pacific Ocean, precipitation is substantial on the west side of the range, with annual snow accumulation of just more than 1,000 inches. Mount Baker in Washington holds a national record for a single-season snowfall in the winter of 1998 to 99 with 1,140 inches, which is 95 feet. Before that year, Mount Rainier held the American record for snow accumulation at Paradise in 1978. However, on the east side of the range, it is a different story. Annual rainfall is as low as 9 inches in the foothills due to a rain shadow effect. As you learned last week, Nevada is the driest state in the U.S. due to the rain shadow caused by the Sierra Nevadas. Rain shadows are caused by mountain ranges that block moist clouds coming off of the ocean. One side of the mountain gets all of the precipitation while the other side stays relatively dry. As you can see in this precipitation map, there is a distinct and obvious difference on the west side versus the east side of where the Cascade Range and the Sierra Nevada are. At the end of this video, you need to watch an educational program put together by Central Washington University that teaches about the rain shadow, not only in the Northwest but around the world. I will give you the website address at the end of this video. Here is the stunning Columbia Gorge. This is where the waterway splits the Cascade Range between the states of Washington and Oregon. This is the only major break within the range. The native tribes of the area developed their own myths and legends about the Cascades. In these legends, Mount St. Helens, with its graceful appearance before the 1980 eruption, was regarded as a beautiful maiden for whom Hood and Adams feuded. Native tribes had their own names for the High Cascades and many of the smaller peaks, including Tahoma for Mount Rainier, Coma Kulshan, or simply Kulshan, for Mount Baker, and Luwala Klo, meaning Smoky Mountain, for Mount St. Helens. In early 1792, British navigator George Vancouver explored Puget Sound and gave English names to the high mountains he saw. Mount Baker was named for Vancouver's 3rd Lieutenant Joseph Baker. Mount Rainier was named after Admiral Peter Rainier. Later in 1792, Vancouver had his Lieutenant William Robert Broughton explore the lower Columbia River. He called Mount Hood after Lord Samuel Hood, an admiral of the Royal Navy. Then, in May of 1792, Mount St. Helens, as seen from near the mouth of the Columbia River, was named for Aline Fitzherbert, the first Baron St. Helens, a British diplomat. Vancouver's expedition did not, however, name the mountain range, which contained these peaks. He referred to it merely as the Eastern Snowy Range. Earlier Spanish explorers called it Sierra Nevadas, meaning snowy mountains. In 1805, the Lewis and Clark expedition passed through the Cascades on the Columbia River, which for many years was the only practical way to pass through that part of the range. They were the first non-Indigenous people to see Mount Adams, but they thought it was Mount St. Helens. When they later saw Mount St. Helens, they thought it was Mount Rainier. On their return trip, Lewis and Clark spotted a high but distant snowy pinnacle that they named for the sponsor of the expedition, U.S. President Thomas Jefferson. Lewis and Clark called the Cascade Range the Western Mountains. The Lewis and Clark expedition, along with the many settlers and traders that followed, met their last obstacle to their journey at the Cascade Rapids in the Columbia River Gorge. Before long, the high white-capped mountains that loomed above the rapids were called the Mountains by the Cascades, and later only as the Cascades. The earliest attested use of the name Cascade Range is in the writings of botanist David Douglas. These rapids are now submerged beneath the Bonneville Reservoir. Exploration and settlement of the Cascades region by Europeans and Americans was accelerated by the establishment of a major trading post, Hudson's Bay Company, at Fort Vancouver. From this base, trapping parties traveled throughout the Cascades in search of beaver and other fur-bearing animals. The Barlow Road was the first land path for U.S. settlers through the Cascade Range in 1845. This formed the final overland link for the Oregon Trail. Previous to this, settlers would raft down the dangerous rapids of the Columbia River. The road left the area that is now Hood River and passed along the south side of Mount Hood at what is now Government Camp, ending in Oregon City. There is an interpretive site there now entitled The End of the Oregon Trail. The original trail was constructed as a toll trail, $5 per wagon, and was very successful. Soil conditions for farming are generally good, especially downwind of volcanoes. This is because volcanic rocks are often rich in potassium-bearing minerals such as orthoclase that decay quickly, giving needed minerals to plants. On the snow-capped mountains such as Mount Hood and Mount Bachelor in Oregon, the storage of water in the form of snow and ice is essential for many reasons. Firstly, the mountains are used as ski resorts. Then, in late winter, much of that water flows into reservoirs to be captured for its potential energy generated by hydroelectric power. Then, the water is used to irrigate crops. These are all good things. Good for our economy, good for having electricity, and good for food. Lastly, the wildlife that calls the Cascades home. First we have black bears, coyotes, bobcats, cougars, beavers, deer, elk, moose, mountain goats, and a few wolf packs returning from Canada live in the Cascades. However, fewer than 50 grizzly bears reside in the Cascades of Canada and Washington. I hope you enjoyed learning a bit of history about the Cascade Mountain Range. Now let's look at the first of two mountains that are within the Cascades. Mount Rainier is a large active stratovolcano located 59 miles southeast of Seattle in Mount Rainier National Park, with a summit elevation of 14,411 feet. It is the highest mountain in the U.S. state of Washington and of the Cascade Range of the Pacific Northwest. In case you were wondering, a stratovolcano, also known as a composite volcano, is a conical volcano built up by many layers of hardened lava, tephra, pumice, and ash. Stratovolcanoes have a steep profile with a crater at the top called a summit. However, some have collapsed summit craters called calderas. Stratovolcanoes have explosive eruptions or effusive eruptions at times. The lava flowing from stratovolcanoes typically cools and hardens before spreading far due to high viscosity. Viscosity means that the lava is partially liquid, sticky, and thick. Scientists believe that Mount Rainier has not produced a significant eruption in the past 500 years. This makes Rainier potentially the most dangerous volcano in the Cascade Range because of its great height, frequent earthquakes, active hydrothermal system, and extensive glacier mantle. Let's break that down a bit. An earthquake is where the earth violently shakes due to the movement in the earth's crust or volcanic action. Here you see where the earth had broken apart in relation to a volcanic earthquake. A hydrothermal system, simply put, is the movement, or rather circulation, of incredibly hot water within the Earth's crust. Since we cannot see through the ground, how do we know that there is an active hydrothermal system? Well, in the case of Mount Rainier, fumaroles have been located. A fumarole is an opening in the planet's crust that emits steam and gases such as carbon dioxide, sulfur dioxide, hydrogen chloride, and hydrogen sulfide. The steam forms when superheated water boils, resulting in pressure that builds up until it pushes a hole out of the Earth's crust to emerge from. On Mount Rainier, fumarolic activity is widespread. The gases coming out of the fumaroles have been sampled and studied by many different scientists since the 1980s. Pictured here is a fumarole photographed atop at Mount Redoubt in Alaska. In case you don't know what a glacier is, it is a slow-moving mass or river of ice formed by the accumulation of snow that is compacted over time. Glaciers are found on mountains or near the North or South Poles. Now, why is Mount Rainier so dangerous due to extensive glacier mantle? Mount Rainier is currently listed as one of the 16 volcanoes with the highest likelihood of causing significant loss of life and property if eruptive activity continues. If Mount Rainier were to erupt as powerfully as Mount St. Helens did in its May 18, 1980 eruption, the devastation would be more enormous. This is because of the massive amounts of glacial ice on top of the volcano compared to Mount St. Helens. Mount Rainier has 26 glaciers, containing more than 5 times as much snow and ice as all the other Cascade volcanoes combined. If only a small part of this glacial ice melted by volcanic activity, the amount of water rushing down would trigger enormous amounts of debris and mud flow to the surrounding valleys. Also, the area surrounding Mount Rainier is vastly more populated. It is estimated that about 80,000 people and their homes are at risk within the debris and mudflow hazard zones. Lastly, the simple fact that Mount Rainier is a much bigger volcano, almost twice the size of St. Helens. Glaciers are among the most visually outstanding and always changing geologic features of Mount Rainier. They erode the volcanic cone and are essential sources of stream flow for several rivers, including some that provide water for hydroelectric power and irrigation. Glaciers flow under the influence of gravity by the combined action of sliding over the rock. Maximum speeds occur near the surface and along the center line of the glacier. During May 1970, the Nisqually Glacier was measured moving as fast as 29 inches per day. Flow rates generally move more swiftly in the summer than in the winter, probably due to the presence of large quantities of meltwater at the glacier base. The summit is topped by two volcanic craters, each more than 1,000 feet in diameter, with the larger east crater overlapping the west crater. Can you see them both? Geothermal heat from the volcano keeps areas of both crater rims free of snow and ice. It has formed the world's largest volcanic glacier cave network within the ice-filled craters, with nearly 2 miles of passages. A small crater lake about 130 by 30 feet in size and 16 feet deep, which is the highest in North America with a surface elevation of 14,203 feet, occupies the lower portion of the west crater below more than 100 feet of ice and is accessible only via the caves. Mount Rainier was first known by the local natives that spoke Salishan as Talol, Tacoma, or Tahoma. As mentioned, the current name was given by George Vancouver, who named it in honor of his friend Admiral Peter Rainier. The map of the Lewis and Clark expedition of 1804 to 1806 refers to it as Mount Rainier. Although Rainier had been considered the official name of the mountain, Theodore Winthrop, in his travel book published in 1862 called The Canoe and the Saddle, referred to the mountain as Tacoma. For a time, both names were used interchangeably. However, Mount Tacoma was preferred in the nearby city of Tacoma. In 1890, the United States Board on Geographic Names declared that the mountain would be known as Rainier. Following this, in 1897, the Pacific Forest Reserve became the Mount Rainier Forest Reserve, and the national park was established 3 years later. Despite this, there was still a movement to change the mountain's name to Tacoma, and Congress was still considering a resolution to change the name as late as 1924. However, today, it is evident that the Mount Rainier name stuck. Well, sort of. In the time leading up to the Super Bowl in 2014, the Washington State Senate passed a resolution temporarily renaming Rainier to Mount Seattle Seahawks until midnight after the Super Bowl. This was in response to Colorado renaming the 53 14ers after the 53 members of the Denver Broncos. After the 2015 change to the original name Denali from Mount McKinley in Alaska, the debate over Mount Rainier's name intensified. So who knows? Maybe someday it won't be Mount Rainier. Typically, up to 5 earthquakes are recorded monthly near the summit. Swarms of 5 to 10 shallow earthquakes over 2 to 3 days take place from time to time, predominantly in the region of about 13,000 feet below the summit. These earthquakes are thought to be caused by the circulation of hot fluids beneath Mount Rainier. Presumably, hot springs and steam vents within Mount Rainier National Park are generated by such fluids. Seismic swarms, which are many shallow earthquakes, are common features at volcanoes and are rarely associated with an eruptive activity. A 2009 swarm produced the most significant number of events of any swarm at Rainier since seismic monitoring began over 2 decades earlier. Here you see a map of swarm activity on Mount Rainier. Then you see what an 8.9 earthquake that took place 6.2 miles below the Earth's surface looks like on a Richter scale. Lastly, you see what a shallow swarm of earthquakes looks like on the Richter scale. At the time of the European settlers, the river valleys and other areas near the mountain was the home of indigenous tribes who hunted and gathered in Mount Rainier's forests and high elevation meadows. Modern descendants of these people are represented by the members of modern tribes that surround the mountain. They include the Nisqually Indian tribe, the Cowlitz Indian tribe, the Confederated Tribes and Bands of the Yakima Nation, the Puyallup Tribe of Indians, and the Muckleshoot Indian Tribe, among others in the area. John Muir climbed Mount Rainier in 1888, and although he enjoyed the view, he conceded that it was best appreciated from below. Muir was one of many who advocated protecting the mountain. In 1893, the area was set aside as part of the Pacific Forest Reserve to protect its physical and economic resources, primarily timber and watersheds, citing the need to also safeguard scenery and provide for public enjoyment. Railroads and local businesses urged the creation of a national park in hopes of increasing tourism. On March 2, 1899, President William McKinley established Mount Rainier National Park as America's 5th national park. Congress dedicated the new park for the benefit and enjoyment of the people. Mountain climbing on Mount Rainier is difficult, involving traversing the most massive glaciers in the U.S. south of Alaska. Most climbers require 2 to 3 days to reach the summit with a success rate of only 50%, with the weather and physical conditioning of the climbers being the most common reasons for failure. About 8,000 to 13,000 people attempt the climb each year. In addition to climbing to the summit, people also enjoy hiking, backcountry skiing, photography, and camping. These are the most popular activities in the park. That was Mount Rainier. Now, moving to the south just a bit within Washington State, we are going to learn about Mount St. Helens. Mount St. Helens, like Rainier, is an active stratovolcano located in southwestern Washington State. The volcano is located in the Cascade Range, which is part of the Pacific Ring of Fire that includes over 160 active volcanoes. This volcano is well known for its ash explosions and pyroclastic flows. Well, we know what ash is, but what is pyroclastic flow? A pyroclastic flow is a fast-moving current of hot gas and volcanic matter that moves away from the volcano. The gases can reach temperatures of about 1,830 degrees Fahrenheit. Pyroclastic flow speed depends upon the density of the current, the volcanic output rate, and the gradient of the slope. The pyroclastic flow hurtles downhill or spreads laterally under gravity at speeds between 62 miles an hour on average, all the way up to 430 miles an hour, the result of which is devastation. That devastation occurred on May 18, 1980. Mount St. Helens erupts, causing a massive pyroclastic avalanche and killing 57 people on this day in 1980. Seismic activity on Mount St. Helens, which is 96 miles south of Seattle, began on March 16th. A 4.2 magnitude tremor was recorded 4 days later, and then on March 23rd and 24th, there were 174 different recorded tremors. The first eruption occurred on March 27th when a 250-foot wide vent opened up on the top of the mountain. Ash was blasted 10,000 feet in the air, some of which came down nearly 300 miles away in Spokane. The ash caused static electricity and lightning bolts. Authorities issued a hazard watch for a 50-mile radius around the mountain. The National Guard set up roadblocks to prevent access to the area. Still, these were easily avoided by using the region's unguarded logging roads. Many residents of the area evacuated, except one. 84-year-old Harry Truman was one resident who refused to move. Throughout April, scientists watched a bulge on the north side of Mount St. Helens grow larger and larger. Finally, on May 18th at 8:32 a.m., a sudden 5.1 magnitude earthquake and eruption rocked the mountain. The north side of the peak rippled and blasted out ash at 650 miles per hour. A cloud of ash, rocks, gas, and glacial ice roared down the side of the mountain at 100 miles per hour. 14 miles of the Toutle River was buried up to 150 feet deep in the debris. Partially molten rock at 1,300 degrees Fahrenheit flowed for miles. The 24 megaton blast demolished a 230 square mile area around the mountain. Geologist Dave Johnston was the closest to the eruption when it blew. He was on the radio that morning and was only able to say, "Vancouver, Vancouver, this is it!" before his truck was pushed over a ridge and he was killed. Millions of trees were scorched and burned by the hot air alone. When the glacier atop the mountain melted, a massive mudslide wiped out homes and dammed up rivers throughout the area. The plume of ash continued to flow out of the mountain for 9 hours, eventually reaching 12 to 16 miles above sea level. The plume of ash moved eastward at an average speed of 60 miles per hour. With ash reaching Idaho by noon, ash from the eruption was found collecting on the top of cars and roofs the next morning as far as the city of Edmonton in Alberta, Canada, and Minneapolis, Minnesota. Locally, the falling ash clogged carburetors, leaving thousands of motorists stranded. 57 people died overall from suffocation, burns, or other assorted injuries. 27 bodies, including that of the stubborn Harry Truman, were never found. By the end of the eruption, the cone, or top, of Mount St. Helens had been completely destroyed. Mount St. Helens lost 1,300 feet in a matter of seconds. Today, analysis of current activity at Mount St. Helens indicates that the volcano remains active and is showing signs of long-term uplift and impending earthquakes. However, there are no signs that a significant eruption will happen anytime soon. Between 2004 and 2008, there were dome-building eruptions at Mount St. Helens. Magma reached the surface of the volcano about October 11, 2004, resulting in the building of the new lava dome on the existing dome's south side. This new dome continued to grow throughout 2005 and 2006. Mount St. Helens showed significant activity on March 8, 2005, when a 36,000-foot plume of steam and ash emerged that was seen from Seattle. This relatively minor eruption was a release of pressure consistent with ongoing dome building. The explosion was accompanied by a magnitude 2.5 earthquake. During this period, there were several transient features observed, such as a lava spine nicknamed the whaleback, which comprised of long shafts of solidified magma being extruded by the pressure of magma beneath. These features were fragile and broke down soon after they were formed. On July 2, 2005, the tip of the whaleback broke off, causing a rock fall that sent ash and dust several hundred meters into the air. Since then, scientists at the USGS Cascades Volcano Observatory, also known as CVO, and the Pacific Northwest Seismic Network, also known as PNSN, have been monitoring subtle inflation of the ground surface and minor earthquake activity reminiscent of that seen in the years following the 1980 to 1986 eruptions. Careful analysis of these two lines of evidence lends itself to the understanding that the magma reservoir beneath Mount St. Helens has been slowly repressurizing since 2008. Repressurization is likely caused by the arrival of a small amount of new magma 2.5 to 5 miles beneath the surface. Pressurization of a volcano's magma reservoir is commonly observed at other volcanoes that have erupted recently, and it can continue for many years without an eruption. USGS and PNSN are continuing to monitor ground deformation and seismic activity at Mount St. Helens. To learn more about the activity beneath the volcano, they will conduct 2 additional types of measurements in the summer of 2020. Surveys will measure the types and amounts of volcanic gases being released and the strength of the gravity field at the volcano. Both types of measurements are sensitive to changes in the amount or depth of the subsurface magma. The information collected at Mount St. Helens continues to help scientists interpret behaviors at other volcanoes and to improve eruption forecasting capabilities. In 1982, land around the volcano was designated Mount St. Helens National Volcanic Monument. The monument, offers many recreational and educational opportunities. Visitors can view the crater, lava dome, pumice plain, and the effects of the landslide. They can also observe animals and plants that have returned to the area. That was Mount St. Helens, a stratovolcano that erupted on May 18, 1980. Now, we are moving far north into the last frontier to learn about Denali. Denali, previously known as Mount McKinley, is the highest mountain in North America, with a summit elevation of 20,310 feet above sea level. Denali is the third most prominent peak on Earth after Mount Everest in Asia and Aconcagua in South America. Located in the Alaska Range in the interior of the U.S. state of Alaska. Denali is the main attraction of Denali National Park and Preserve. The mountain has two peaks, the southern peak being the higher. The upper two-thirds of the summit is covered year-round in snow and immense glaciers. The Koyukon people who inhabit the area around the mountain have referred to the peak as Denali for centuries, meaning the High One. In 1896, a gold prospector named it Mount McKinley in support of the then presidential candidate, William McKinley. That name was the official name recognized by the federal government of the United States from the year 1917 all the way until 2015. In August of 2015, the United States Department of Interior announced the change of the official name of the mountain to Denali. In 1903, James Wickersham recorded the first attempt at climbing Denali, which was unsuccessful. The first verifiable ascent to Denali's summit was achieved on June 7, 1913 by climbers Hudson Stuck, Harry Karstens, Walter Harper, and Robert Tatum, who went by the South Summit. In 1951, Bradford Washburn pioneered the West Buttress route, considered to be the safest and easiest route, and therefore the most popular in use. The Japan Alpine Club installed a meteorological station on the ridge near the summit of Denali at the elevation of 18,733 feet in 1990. Then, in 1998, this weather station was donated to the International Arctic Research Center at the University of Alaska Fairbanks. In June 2002, a weather station was placed at the 19,000-foot level. This weather station was designed to transmit data in real time for use by the climbing public and the science community. During the winter of 2003, the weather station recorded a temperature of negative 74.4 degrees Fahrenheit combined with a wind speed of 18.4 miles per hour to produce a North American record wind chill of negative 118.1 degrees Fahrenheit. Even in July, this weather station has recorded temperatures as low as negative 22.9 degrees Fahrenheit and wind chills that bring the temperature down as low as negative 59.2 degrees Fahrenheit. We've finished our final destination for this week, Denali. I hope that you have enjoyed learning about some of our Northwest mountains in the United States. Your homework for this week will be doing your initial worksheet for the Northwest Mountains that include all of today's lesson. Then, on 2 separate days this week, complete 2 of the worksheet called Memorization Through Repetition, which includes the new geography learned today, plus the last 3 lessons. Also, don't forget to view this brief video on rain shadows located at bit.ly/RAINSHADOW3. As always, I pray that you and your families are healthy and safe. Bye for now.